Welcome back. Elementary Probability Theory, Chapter 5. Section 5.1. What is probability? Focus points of this section. Assign probabilities to events. Explain how the law of large numbers relates to relative frequencies. Apply basic rules of probability in everyday life. Explain the relationship between statistics and probability. Okay. What is probability? When we use probability in a statement, we are using a number between 0 and 1. Okay, so notice probability has to be between 0 and 1 to indicate the likelihood of an event. Probability is a numerical measure between 0 and 1 that describes the likelihood that an event will occur. Probabilities closer to 1 indicate that the event is more likely to occur. Probabilities closer to 0 indicate that the event is less likely to occur. All right. 1 has to be thought of as 100%. 0 has to be thought of as 0%. So your probability is a certain percent between 0 and 100%. Probability is closer to 1, they are closer to 100%. That is, indicate the event is more likely to occur. Probability is closer to 0, which is 0%, indicate that the event is less likely to occur. So probability is closer to 100%, more likely to occur. Probability is closer to 0%, less likely to occur. Okay. Now, PA is read P of A. That parenthesis is read as of. P of A denotes the probability of an event A. If P of A is 1, event A is certain to occur. So if probability of A is 1, then event A is certain to occur. If probability of A is 0, event A is certain not to occur. Okay, so 0 is you certainly A will not be occurring. If probability is 1, then you're certain that A will occur. Probability assignments. A probability assignment based on intuition incorporates past experience, judgment, or opinion to estimate the likelihood of an event. A probability assignment based on relative frequency uses the formula. Probability of an event is relative frequency, which is F over N. So probability is relative frequency. Okay. So this is your formula. If you're using intuition, then that's, you're estimating the likelihood of an event based on your past experience. Now, a probability assignment based on equally likely outcomes uses the formula. Probability of event is number of outcomes favorable to event, total number over total number of outcomes. Okay, these are notions you will understand when you try various problems, concrete problems. Okay, so let's look at an example. Consider each of the following events and determine how the probability is assigned. A sports announcer claims that Sheila has a 90% chance of breaking the world record in the 100-yard dash. So what is this 90%? It is likely the sports announcer used intuition based on Sheila's past performance. So this is an example of intuition-based probability, 90%. Here is another example. Henry figures that if he guesses on a true-false question, the probability of getting it right is 0.50. Now, what is this? In this case, there are two possible outcomes. Henry's answer is either correct or incorrect. Since Henry is guessing, we assume the outcomes are equally likely. You see, because Henry is guessing, so he might guess it correct, he might guess it incorrect. So both outcomes are equally likely. There are two equally likely outcomes, and only one is correct. So probability of the correct answer is number of favorable outcomes 1 out of total number of outcomes 2, which is half. Half is 0.50. Here is yet another example. The Right to Health lobby claims that the probability of getting an erroneous means incorrect, medical lab report is 0.40 based on a random sample of 200 laboratory reports, of which 80 were erroneous. 80 out of 200 were erroneous. So here you are using relative frequency. So probability of an error is the relative frequency. 80 in erroneous out of total 200. You see, sample size is 200, number of errors is 80. All right. So there are these three examples. 1, intuition. 2, number of favorable outcomes over total number of outcomes. And 3, basically frequency. All right. 80 out of 200 where so the error had a frequency of 80. Relative frequency is 80 out of 200. All right. Now, the technique of using the relative frequency of an event as the probability of that event is a common way of assigning probabilities and will be used a great deal in later chapters. Okay, so using relative frequency as probability of that event is the most common way. All right. The underlying assumption we make is that if events occurred a certain percentage of times in the past, they will occur about the same percentage of times in the future. All right. So there is an underlying assumption here. Okay. This assumption can be strengthened to a very general statement called the law of large numbers. What is the law of large numbers? In the long run, as the sample size increases and increases, the relative frequencies of outcomes get closer and closer to the theoretical or actual probability value. The law of large numbers is the reason businesses such as health insurance, automobile insurance, and gambling casinos can exist and make a profit. No matter how we compute probabilities, it is useful to know what outcomes are possible in a given setting. So let's understand this law of large numbers. All right. So you see, here was a very beautiful example. Here is a medical lab. They took a random sample of 200 reports, out of which 80 were erroneous. So probability of error is said to be, in this case, 80 out of 200. Well, what if you had taken 400 lab reports? Well, we expect it to be double this. If I have doubled it, I would double it. That's an expectation. So that is what, as the sample size increases and increases, the relative frequencies of outcomes get closer and closer to the theoretical probability value. So whatever is the actual probability value, you are probably going to approach that particular value. All right. Now here is another example. Human eye color is controlled by a single pair of genes, one from the father and one from the mother, called a genotype. Brown eye color B is dominant over blue eye color. Therefore, the genotype of B, consisting of one brown gene B and one blue gene, the brown gene dominates. A person with a B genotype has brown eyes. If both parents have brown eyes and have genotype B, what is the probability that their child will have blue eyes? What is the probability the child will have brown eyes? Okay, so let's look at father has these options. Father has options brown, and this is for the blue. Mother brown, and this is for the blue. If both father and mother have brown genotype, that's one option. Mother is blue, father is brown. That's another kind, and so on. Okay. So here is the different possible eye color combinations according to genetics, right? So the four possible genotypes are equally likely. To compute probabilities, blue eyes can occur only with the blue genotype. LL for blue. You see? So father has brown, mother has brown. Father has brown, mother has blue. Well, you want both the parents to have blue for the eye of the child to be blue. So there is only one option out of four. Number of favorable outcomes over total number of outcomes. So on the other hand, the probability of having brown eyes is the rest of it. This guarantees you a blue, the rest guarantee you, well, get you brown eyes. Okay, so we'll come to the next slide on the next video. Until then,